Assalamualaikum and good morning, Doctor. My name is Nurfathiah Binti Rahim and my matric number is 22136312. Today, I will present about the task I complete during my internship. Before I explain my internship experience, I would like to briefly introduce the company where I complete my industrial training. Microenergy Sdn Bhd was established in 2011 and is located at Menara K1 Kuala Lumpur. The company is one of the leading solar energy companies in Malaysia, provide a sustainable solar energy solution for residential and commercial. The company is committed to promoting renewable energy and reduce carbon emission by delivering high-quality solar PV system. Microenergy expertise include photovoltaic system design, project management, solar system installation, testing and commissioning, solar system maintenance, and IPP licensing. This service enables the company to manage a solar project from the initial design stage through installation, testing, commissioning, and long-term maintenance. During my internship, I was attached to the project department as a project intern, where I gained practical experience in project coordination, technical documentation, site activities, and testing commissioning of solar system. To ensure that every solar project is completed efficiently, Microenergy Holding has a well-defined organization structure where each department has its own responsibilities. During my industrial training, I was assigned to the project department as a project intern under the supervision of Mr. Indiran. My first technical task was to understand the main component used in solar photovoltaic system. Before visiting project site, I learned the function of each component such as solar panel, railing, tail hook, L-hook, and clamp. This knowledge helped me better understand the installation process and enable me to communicate more effectively with engineers and contractors during site visit. I learned about the type of solar panel used by the company during their installation project. One of the solar panel brand used by Micro is ICO with power rating of 510 watt, 535 watt, and 545 watt. The panel selected for each panel depends on the system design and customer request. The standard dimension of these ICO panels are 1955mm in length and 1134mm in width. The function of solar panel is to convert sunlight into direct current electricity. The electricity generated by multiple panels is connected into string before being sent into the inverter for conversion into alternating current, AC. Next, there is railing used during installation. The standard railing used by Micro is 4200mm. The railing acts as the main support structure that holds the solar panel securely on the roof. After that, if the house uses roof tile, we use tile hook. The main function is to support the railing while minimize damage to the roof tile. The number of tile hooks used depends on the total number of solar panels. For example, 4 panels require 12 tile hooks. Other than that, if use metal deck roof, we will use L-hook instead of tile hook. It provides strong mechanical support and help ensure that the solar panels remain stable and even under strong wind conditions. Lastly, end clamp and mid clamp are used to secure the solar panel onto the railing. The end clamp is installed between the both ends of the solar panel, while mid clamp is installed between two solar panels. This clamp prevents panel movement and ensure the entire solar panels remain firmly attached to the railing structure. One of the technical skills I learned during my internship was how to read and understand a single line diagram. The SLD showed the complete electrical connection of the solar PV system using a simplified diagram. By referring to the SLD, I was able to identify the major components such as the solar panel, inverter, and AC box. From the SLD, I learned that the solar panels generate direct current. The DC power from the solar panel is connected in string and then flows into the inverter. The main function of the inverter is to convert DC power into AC power. After the power is converted, it flows from the inverter to the AC box. From the AC box, the electricity is connected to the client DB box, where it is distributed to the electrical load inside the building. Besides understanding the power flow, I also learned how to determine the expected voltage for each solar by referring to the SLD. For example, If each solar panel has a VOC of 50 volt and one string consists of 10 panels, the expected voltage will be approximately 500 volt. During the testing and commissioning process, we measure the actual string voltage using a multimeter and compare it with the calculated value. The measured voltage should normally be plus minus 5% tolerance based on SEDA TNC. If the measured voltage is significantly lower than the expected value, it may indicate several possible issues such as a solar panel is missing or not installed, a loose or disconnected MC4 connector. After installation was complete, I will follow the project engineer to do the testing and commissioning process. During this stage, I check whether every component was functioning properly or not, and do the inspection include checking inverter operation, cable connection, system voltage, communication status, and monitoring through the inverter application. I also observe the engineer ensure that the solar system operates safely before handover to the customer. Before installing a solar PV system, the first step is to determine the customer electricity consumption. For building with a connected load of more than 72 kW, a load profile study is carried out. The purpose of the load profile is to monitor the building electricity consumption pattern, include the peak demand and energy usage over a period of time. This information helps the engineer design a solar PV system with an appropriate capacity based on the customer actual load profile. As part of this process, I had the opportunity to follow site supervisor during the installation of a power logger. A power logger is used to monitor electrical parameters such as voltage, current, power, energy consumption, and demand. During this task, I observed the installation procedure, I learned the wiring connection, and understood the importance of collecting accurate electrical data. As part of my internship, I have the opportunity to accompany the project engineer and site supervisor during several site visits before the solar PV installation began. During this site visit, I learned how to plan the cable routing for the solar PV system by identifying the most suitable path for both the DC and AC cables. Proper cable routing is important to ensure a neat installation, minimize cable losses, and protect the cables from damage. I also learned how to determine a suitable location for the inverter and the AC box. When selecting the installation location, several factors need to be considered, such as the distance between solar panels and the client DP box. Besides that, I observe the roof condition, verify the installation area, and ensure that the proposed installation follow the approved system design. I also assist the project engineer during battery configuration. The configuration process involves setting communication between the inverter and battery. Correct configuration is important because it ensures the inverter and battery communication properly for charging, discharging, and backup operation. This task helped me gain practical knowledge of battery energy storage system. Besides technical work, I was also responsible for documentation. One of my daily responsibilities was updating the residential installation progress. I recorded installation status, monitor project completion, and update the project database to ensure all information remain accurate and up to date. Next, I was assigned to checking the bill of material before it was approved for procurement. My task was to print the BOM and review it by checking whether the list materials, quantities, and specification match the project requirement. If I found any missing information, I will inform the project engineer for correction. Once I had complete the initial review, I will pass the BOM to the project engineer for verification and a final review. If there were no further correction required, the engineer will approve and sign the BOM. After obtain the engineer approval, I will forward the signed BOM to the procurement department so that they could proceed purchase and preparing the required material for the project. This task taught me the importance of accuracy in project documentation, as any mistake in the BOM could lead to material shortage, procurement delay, or additional project costs. Another task that I need to do was monitor material in and out for Max's project. I check stock level, monitor incoming and outgoing material, and coordinate with the store person to ensure material are available before installation. This helped prevent installation delay caused by insufficient materials. After completing the site visit or TNC, I was responsible for preparing the required reports. For the site visit report, I recorded the site condition, observed and any issue found during the site visit. For the TNC report, I documented all the testing activities, measure value and any issue identified during TNC. This report serves as a record to show that the system has been tested before being handed over to the client. I also prepared the inspection checklist where I recorded all the inspection items checked during TNC, such as the earthing system, cable management, cable termination at the client DBs, and city claim installation. If any issue were found, they were recorded so that the contractor could carry out the necessary rectification. These reports are important because they provide a complete record all of activity and inspection carried out on the site. Lastly, my task was update the project progress using the capture system and prepare the MOM after project meetings. Throughout my internship, I faced several challenges. One challenge was dealing with difficult clients who sometimes not satisfied regarding installation schedule or project delays. Another challenge was responding to unexpected technical questions for client, which required me to continually improve my technical knowledge. Lastly, I also had to manage multiple tasks within limited deadline while ensuring my work remained accurate and well organized. This experience strengthened my communication, problem solving, and time management skill. In conclusion, my internship at Micro Energy Holding provided me with valuable exposure to both technical and documentation aspects of the solar PV industry. I gained practical knowledge in solar system component, installation process, testing and commissioning, project documentation, and project coordination. This internship has strengthened my technical skill, communication abilities, and confidence to work in engineering field. Thank you for your attention.